No.
Actually, Daniel.
All right, for number 3, it's asking us to evaluate.
Okay. I'm very. I'm just insane.
What does it mean to evaluate? Replace and solve, yes. So we're going to replace -3 anytime we see an x. We should be using parentheses when we do this. You can put this directly in your calculator, put all of that in. I'm going to just do it by hand. But you should have gotten 3. So if you did not use parentheses, you got a different answer. You have to use parentheses with negative bases.
Should have calculated.
Well, that's also because you knew it was 9. So that was
Wow, that takes hard.
okay. My hint for number 5 is start at the point they give you and use your slope.
Okay.
Start at what?
Start at the point and use your slope.
Wait, how is it 3?
I don't believe it.
What part don't you understand on how we got 3?
Wait, if you put that bad boy into the
No, I
calculator.
saw Mr.
Use
Vincent.
parentheses.
Because
If you don't use parentheses,
Yeah, you use parentheses.
Oh, yeah, that's not why I am.
But I did it all individually.
Guys,
Did you put the square thing?
if you don't use parentheses or if you just do this, remember this is the same thing as -1 times 3 squared. Those are 2 different things. You have to use parentheses. Right? Make sure you have that answer written down and pass up your answer sheets.
That was the model. Oh, I'm home.
Alright, we're done. Maybe if you just put that back point
I am okay with the
you got that long wingspan, right?
So yeah.
You got that long. Get up.
You know what air is?
Michael, go back to your seat.
You should do it.
Ozzy Osbourne hitting a bat, I wouldn't even do a Pomeranian.
Have a seat. We are going to go over the SOL review. Once everyone is quiet. Remember, if you are not doing this, you are losing practice that you could have. You need to go back and do it. Copying it down won't give you that practice you need to prepare for the SOL.
What's SOL?
Alright, now I will say, and reiterate this again. Remember that I've said that you could use Desmos to solve these, so after like the first one, I stopped solving it by hand and I used Desmos. So if you need a refresher on how to do that, we can do that after I go over these answers. Number 1, when you solve this, you should have got x equals 0. Number 2 and 3, I expected you to put those directly into Desmos. You should have gotten 2 answers for both. X equals -4/3 or the decimal -1.3 repeating, and 2. For number 3, your answers were -6 and 2/5 or the decimal 0.4. Now, later when I actually show you how to solve these and how to do this, this is an app on your calculator. I will show you how to use that and work that. And then this is how you would actually solve it. So that's up there, but we'll go more into depth about that later. These, it asks you to describe. So your answer should have been things like no solution, infinitely many solutions, one solution, and what that solution was. 4 was no solution. 5 was one solution, and that solution was 0. 6 and 7 were both infinitely many solutions. 8, the answer was C. The only solution is 0. 9, the answer was D. X equals 7. And 10, the answer was -12.5.
We're gonna have Desmos on that as well, right?
Yeah. Do we have questions on these 10 or need a refresher on how we do this in Desmos? John? For which one? For 7. Every time I think this is up, it's not. Okay, for all of these questions, you could have put this directly into Desmos, but you need to do them separately. Put one side of the equation in and then the other. So if I put in 5 times x plus 4 plus 16, and then I put the other side 2x plus 3 times x plus 12, I need to zoom out to see where they intersect. And if you keep zooming out and you don't see the other line, more than likely it's the same line. So to see that on Desmos, hold on 1 second. Go into your gear, go into the color, whichever one, it doesn't matter, and change the type of line. So I can make this a dotted line, and you see that they lie on top of one another, so that means it's infinitely many. Yes. So I'm going to do that just to show you what it looks like. When you put the entire thing in, nothing happens. It's like it froze. It doesn't know what you want it to do. But when you put them in separately, it can show you the 2 different lines. Aiden, did you have a question? Yes, sure.
Can this still work when we have like that with X? Is it something like for the 2 for the
Yeah, you would just put in those 2 problems. you wouldn't put f of x in. You would just put in 3x plus 4 and x minus 2. You're going to get this U shape. Hold on 1 second. And then anytime you get the U shape and it's asking for solutions or roots, you just find the x-intercepts. Yes.
Are we going to be able to use Desmos on that stuff?
Yes.
That seems slow. You guys need to man up.
At the 3600.
I know I put 16 up there already, but just in case you didn't get it, that was the answer to 16 for 4B. I had said that there were some vocab that we hadn't gone over, so I'm going to just quickly go over them really fast. Anytime you see the words property of equality, that just means what you do to one side, you do to the other. Additive inverse means if you are adding or subtracting two numbers that are inverses, they become 0. Additive identity is if you are adding something to 0, it's just whatever you added, it's itself. Multiplicative inverse is if you are multiplying two inverses, they become 1 when multiplied or divided. The answer to 17 was C. You added on both sides, so that should have been C. We'll go over 4C when we get back from lunch, so you guys can grab your phone. Yes.
So we go back to the Did you like our presentation sound?
Yeah.
Nice walk here again. Definitely said that you guys
Cameron,
Yeah.
you still owe me that one.
A minute? Alright.
Have a good night.
What do you mean?
Thank you.
Oh yeah, you got it. I forgot what
All right, let's go over this last section. So I'm going to say the answers, and then if we need to go over how to do it, we'll do that. For number 18, the answer was 2a over a minus b equals h. For 19, the answer was a equals q over 3 plus 5c. 20a was h equals s minus 2b all over p, or s over p minus 2b over p. Either one of those is fine. And then same kind of thing with b. B equals S minus HP all over 2, or this is S over 2 minus HP over 2. Chris, go go and sit down. Can you shut the door? Can you shut the door? Thank you. Do we have any questions on these four? Okay. Couple things about your schedule. You'll see that we are going to take our quarter test before we take this current unit test. That means this current unit won't be on that quarter test. I do have those quarter test reviews ready for you guys, but I wasn't planning on giving it to you until next week. If you would like it prior to then, you just have to let me know. Anything radicals related will be on the next quarter. So this test, these Khan Academy assignments. Notice that there's not a quiz just because of the Khan Academy assignments, and I'll be able to see if you understand this in class. Also, it says unit test twice. One of those is a typo because it just says it's the same thing. What's your question? Look in your notes for the radicals notes. Yes. It says radicals on the top. Alright, so radicals are like your square roots, your cube roots. It's just a different name for it. So our goal in this unit is, can we simplify radicals? In order to do that, we need to know some of the basics. What is the square root of 4? 2. The square root of 16? 4. So you should be asking yourself, what times itself will give us this answer? The square root of 25?
5.
The square root of 81?
9.
Okay, so 9 times 9 equals 81, 5 times 5 is 25, 4 times 4 is 16, and then 2 times 2 is 4. But now when we have these cube roots, we're thinking what number multiplied to itself 3 times will give us whatever is inside.
What?
So for 27, think of a number that if we multiplied it, that times that times that would give us 27.
3.
3. Because 3 times 3 is 9, and then 9 times 3 is 27. So the cube root of 27 would be 3. What would the cube root of 64 be? 4. Because 4 times 4 is 16, and then 16 times 4 is 64. What about 8?
2.
Because 2 times 2 is 4, and then 4 times 2 is 8. Now, we are going to deal with some that won't give us these perfect squares. In your calculator, I want you to type in the square root of 8. So you get decimals. When we simplify these, we don't want those decimals. So we're trying to simplify this as much as possible without getting decimals, which means somewhere in this, we're going to end up with a square root still in our answer. We have to simplify until it's the most simplified square root. So the way we do that is we need to think of 2 factors of 8. 4 and 2. So we're going to make like a factor tree. And we're going to keep breaking these down until we get to prime numbers. So that means the only factors the number would have would be 1 and itself. 2 is a prime number because its factors are 1 and itself. Can we break down 4 to what? 2 and 2. And then once you get to this step, you're looking at, do you have any pairs? Because this is square root, so square, I think, 2. Do we have any pairs? Yes. We have a pair of 2's. Anytime we have a pair, that pair gets to come outside of the square root. Anything that doesn't have a pair stays inside. You can think about this like they're breaking out of jail. You need a friend to get out of jail. You don't have a friend, you stay in jail.
Man, I'm gonna stay in jail forever.
Okay? So, in this case, that pair of 2's, we had 1 pair of 2's, so 1, 2 came outside of the square root, and there was 1, 2 left inside the square root. So this would be our simplified answer. 2 times the square root of 2. You guys haven't done this part yet. Now, I want you to put 2 times the square root of 2 in your calculator now. You're supposed to get a decimal.
Yes.
It's the same number.
And it should be the same exact number. That's how you know you simplified this correctly. If you get 2 different answers or 2 different decimals, you didn't simplify this correctly. Right, let's keep going. Give me 2 factors for 18.
9 and 2.
So there's 2 different ones. We're going to end up doing both. Just to show you they both work. So let's do 9 and 2 first. And then we'll go back and do 6 and 3. Could we break either one of these down?
Yes.
Yes. What?
9.
To what and what? Do we have a pair?
Yes.
Yes. So the 3 would come out, and there's a 2 left inside. Now, because as you get higher in numbers, you have more factors, it doesn't matter which factors you choose as long as you are 2. Hmm? 2 numbers, yeah. Because you'll have different factors, it doesn't matter which factors you use as long as you simplify it all the way. So let's say we did 6 and 3 instead. Could we break either one of these down?
Yes.
6 to what and what?
2
2 and 3. We still have a pair of 3's, even though they're not with each other.
So it's 3.
So it's still 3 times the square root of 2. Yes. As long as that was the last numbers you did. So like this 3 was, we didn't do anything else with it. These were the last things we did with that 6. Aiden, you had a question.
No, was
Okay. Yes.
What if you find one that doesn't have a pair?
Like the number itself is prime?
Or, yeah, maybe something like that.
So like if you had the square root of 2, its factors are 2 and 1, and that doesn't simplify. So you could have a case like that.
So it would just be like 1 instead of 2 or 2?
So, okay. So if you had something like the square root of 2, its factors are 2 and 1. Neither of those are a pair, so that means this would stay inside. You wouldn't have anything
It should be 2 times 1.
which is just 2. Now, we'll do more examples so that you see what happens when you don't have other pairs. What are 2 factors of 20? 5 and 4. You could also do 10 and 2. It doesn't matter. I'm not going to do both again, but either one would work. Sometimes, depending on the factor you choose, you have to simplify more or do your factors more. 4 we can break down to 2 and 2. What would our final answer be? 2 times the square root of 5.
So if there's a number that's not, if there's a number that isn't like paired up, then we do,
This 5, so it didn't have a pair, so that stayed inside. Anything that doesn't have a pair stays inside.
okay.
Aiden. Did you have a question? Did you have a question?
Me?
Okay. Yes, Mary.
So for 18, for the square root of 18, it would be 3 and 2.
3 times the square root of 2.
Yeah. Okay.
For 27, give me 2 factors. 3 and 9. How could we break this down more? 9 to 3 and 3. Do we have a pair? Yes. It doesn't matter if I chose these 2 or these 2 since they're all 3s. The 3 would come out and you have 1 left in. Now, with 32 you have 8 and 4, you have 16 and 2. I was thinking there was another one, but it doesn't matter which ones you choose. You can simplify 8. You can simplify 4 as well. So to what and what? 4 and 2 for 8. And 2 and 2. Can we simplify any more?
Yeah.
The 4 to 2 and 2. Now in this case we have multiple pairs. That's okay, that will happen. So you have 2 groups of 2 that get to come out. So anytime you do that, remember everything is always multiplying. So you would need to multiply 2 and 2 to get 4.
So because there's 4, if you just so since there's 5
just write
2s,
Hold on, because there's 3 different questions going on. 3's, then Mary, then Noel. Mary.
alright, so there's 1, 2, 3, 4, 5 2s, but we're only multiplying 2 twice, and we have 1 in the thing.
There's only 1 that doesn't have a pair.
Oh, okay, so that goes in the middle.
That goes inside.
And then the pair is inside. Okay.
What's your question?
Can you just stop at the second row triangle and just
Right here.
put it at the top 4?
You said take this 2
No,
and
she's saying can you stop at that? Oh yeah. So now the 4 is there and you need to simplify it?
no, you would need to keep going. These need to be broken down completely, Jackson.
Do you have to write the 2 times 2? You just write the 4.
You could just write 4.
So you have to put the number of groups outside and then the number of on the inside.
Yes. So just in case you didn't hear those 2 questions, pairs go on the outside, anything left over is on the inside, and you don't need to write 2 times 2, you could have just wrote 4. Okay? Do we have any questions about this right now? Alright, I'm going to do one of these and then I'm going to let you guys try some. For this, notice that this is the same thing we just did. So we should have similar answers. And there's two ways I'm going to do this. So let's say I didn't have this already worked out. I would need to work it out, so I'm going to do it again. It's just going to be this again. I'm going to pretend the 6 isn't there for a second, and then I'll bring it back later. Actually, I'm going to do 16 and 2 this time, since we did 4 and 8. We still have those two groups of 2. The 1, 2 is still left inside. We knew that should have still been the answer because that's what we just got above. But this entire thing is being multiplied by 6. So you would multiply it by 6, but you would only multiply the outside by 6. So 6 and 4. Right now, we are not multiplying anything inside. So if you have numbers outside, they only multiply to what's outside. Okay? Now, I said there were two ways you could have done this. So because we knew this already, or let's say that you've been seeing the square root of 32 a lot, you know it's 4 square root of 2. If you knew that part, you could have started here and just multiplied it from there. But I would like to see that process. I really don't expect you to remember any of these numbers because they're going to change and be different all the time. But I will say the easiest one is 8 because it's 2 root 2. 2 square root of 2. I want you to go ahead and try those 4. And then we'll come back and we'll talk about those answers.
You can meet later.
Oh, wait.
Yeah, we can have COVID-19.
Alright, for these, since we already have the square roots worked out, that would be these numbers that we already did. I'm just going to rewrite those down here. And then write the final answer. So 4 times the square root of 2, 15 times the square root of 2, 6 times the square root of 5, and 12 times the square root of 3. Highly.
Wait. What happened to the 27?
We broke it down.
How?
What? 3 and 9.
Oh, yeah, look at the
That broke down to 3 and 3.
Okay. Oh, I get it.
Curious, you had a
What's 10
question?
times 5?
You had a question. Now, before we get into the variables part of this, I just want to show you another way to go about this. So if you like the factor tree, that's fine, continue to do it. And then if you like this other method, you can do that. So it'll be your choice. We're going to list out the perfect squares. So meaning 1 squared is 1. Write this somewhere on your paper. 1 squared is 1. 2 squared is 4. 3 squared, 9. 4 squared. Keep going.
121.
Oh, we're just going to stop at 100.
I think 121.
But yes, 121, 144, 169, 14 always just Now,
You're right.
to do it with your perfect squares, you need to know your factors. So when you do your factors, I know that the square root of 8 is 4 and 2. Are one of those numbers a perfect square? Which one? 4. So I know 4 is a perfect square. The square root of 4 is what? 2. Whatever the square root is would go outside, and then the other factor would go inside. We can do the same thing for all of these. For 18, now if you chose 6 and 3, it wouldn't work. This method wouldn't work because 6 or 3 aren't perfect squares. But 9 is. So if you choose a perfect square, then it works perfectly. The square root of 9 is what? 3. So 3 would go on the outside. And then the other factor would go on the inside. For 20, if you chose 4 and 5, 4 is your perfect square. So 2. And that would go outside. And then your other factor, 5, would go inside. 27 would work the same way. I'm going to skip that one and go to 32. There are. We just stopped at 100 because you won't really see much higher than that. So in this case, we have 4, but because 8 can still be simplified, you don't want something like that. You want something with the highest perfect square. So like when we did 16 and 2, 16 is a perfect square. 2's not, but I can't simplify 2 anymore. The square root of 16 is 4, which would be the number on the outside. And then your other factor would be the number on the inside. So if you like that method, you could use it. But if you like the factor tree, do that. I'm going to show you 2 different ways to do these as well. But first, we're going to start off by expanding. How would I expand x squared? X times x. Do we have a pair? Yes. And we don't have anything left over, so the x would come out, and there would be nothing underneath the square root. It would just be x. Now, you should recognize that the square root and the square, they're inverses, so they would undo each other anyway. Yes. 2 pairs that would stay on the outside, which is x squared. So both pairs would come out, and you would need to simplify it to x squared. So in this case, when you have variables, you need to remember your exponent rules. When you are multiplying like bases, you're adding your exponents. Yes?
Is that just making it smaller?
Yes, that's what you do when you take the square root of something. You make it smaller. Now, let's do one more of these. X to the third would be x times x times x. Do we have a pair?
Yes.
Yes. We have one pair. So we have one that would come out and one that would stay in.
And the one that's left out is the one that was, whatever's left out.
Say that one more time.
Whatever's left out, go inside.
No. This
Yeah,
x,
yeah, that.
whatever is left out of a pair, would go inside. Yes. Now, the other way to do this, and this will work only with your variables, it won't work for your numbers, but you could use this method for every single time. This is a square root, so I can pretend there's like a 2 outside here. And I'm going to think about this like division. 2 goes into 2 how many times? Once, with nothing left over. If there was a 2 outside here, 2 goes into 4 how many times?
Twice.
Twice, with nothing left over. For this one, 2 goes into 3 how many times? Once, with 1 left over. So this method will always work for your variables.
We just use 2.
For square roots. For your cube roots, it's going to be a little different. So we're going to go back to expanding for a second, and then we'll go back to that rule I was just talking about. So anytime we had a square root, we were looking for a pair to come out. But now that we have cube roots, we need a group of 3 to come out. No longer pairs. Yes.
The x5 one, if we did the 2 into it, it would be twice, right? It would be x squared and then x side.
Yes. So in this case, we have, this would be x times x times x. Every time we have a cube root, we need a group of 3, no longer a pair. But we have a group of 3 here. So that group of 3 would get to come out. It would just be x. The cube root and something cubed, those are inverses, so they would undo each other. If I had something like, I'm actually going to skip this one. I'm going to go into this one. This would be x times x times x times x times x. I feel like I misdid that. Do we have a group of 3 in this case?
Yes.
Yes. We have one group of 3, so that one group would get to come out.
And then the rest would go inside.
The rest would go inside, but we have 2 of them,
It would be x times x.
so it'd be x times x, which is
X
x squared. But this is also a cube root, so we need to make sure it stays a cube root.
And then you put cube root on the outside, and then you square it, it is on the inside.
So it'd be x times the cube root of x squared. Yes.
So if you had like a cube root and then there's like multiple pairs, if there's like 2 pairs of the option, would that be x divided by power?
Sorry, say that one more time.
So if it was like the one you just did, and you had a, and it would be 2 roots of 3, and then an extra x, would that be x divided by 9?
No.
The same 3.
No. If you had 2 groups of 3, it would be x times x outside. So that'd be x squared.
Then why x squared?
It's not. This is the cube root of x. So if you want to, you can use parentheses. So you have to remember that this is a cube root and it's not being raised to the 3rd power.
Then at the end for the answer, you put 3 as a cube for that.
Yes. You have to put 3 outside of this, otherwise it's not the right answer. Just remember to put a 3 there for your cube roots. That same rule I was just saying still applies here. There is an actual 3 here. 3 goes into 3 how many times? Once, with nothing left over. 3 goes into 5 how many times? Once, with how many left over? 2. So you could still use that rule as long as it's only with exponents. I'm sorry, with variables. I want you to try these three. And then we'll come back and talk about it. The ones that are left. Yes.
Oh no, Gary touched me. That's Shakaya.
Wait, why is the X on the outside of 2 instead of the one on the inside?
Because it goes into separate.
For which one? Jackson, Aiden, have a seat. So your three answers should have been x squared times the square root of x, x cubed, and x squared times the cube root of x. So remember that you have to put that cube root, or put the 3 like right outside of the root. Questions on those? On the back.
Oh.
Oh yay.
Fine.
So notice that now you have numbers and variables. You're going to take what we just did with 2 different things and put them together. So let me show you how that works. You kind of do them a little separate. Yeah. So factor tree. Give me 2 factors of 20. We can break down 4 to 2 and 2. We have a pair of 2s. That will come out, but I'm going to hold off on doing that one for 1 second. X squared can be rewritten as, that is 1 pair that will come out. Or you can use your 2 goes into 2 1 time.
So would it be 2x and then 5 inside?
Yes. So it's the same thing we were just doing. It's just combining your numbers and the variables now. Aiden.
Would it be the same thing on the bottom one except we put
So what if it's, say it was like x times x times x, and it came out to x squared, it would be 2x squared. And
Right now, I'm going to use the different method. So let's say I'm using my perfect squares and I'm using the rule with the numbers. I know 16 and 2 work for 32. I know 16 is a perfect square and it's the highest perfect square that's a factor. The square root of 16 is what? 4. I'm going to write that, but I haven't written my answer yet. Sorry, say that one more time. We will in 1 second. If there's an imaginary 2 out here, 2 goes into 3 how many times? Once. So there would be an x outside and 1 left inside. We know this 4 would come outside and this 2 would go inside. There's this space here, but there really shouldn't have been. So 4x times the square root of 2x. Now you could have done your factor tree also. I just didn't in that case. Right? You will have some time to work through some of these here in a second. Just like with your variables, when you have cube roots, you need groups of 3. Your numbers also need groups of 3. Give me 2 factors of 16. 8 and 2, 4 and 2, and then 2 and 2. We have a group of 3. So that would be 1 group of 2 that comes out.
Not the other 2.
The other 2 would stay inside. For our x's, in this case we have 3.
Oh.
We have a group of 3 x's. All of those would come out. Yes, Chris.
Like from the 8 to 4 and 2, is it because 4 multiplied by 2 is 8?
Yes.
Oh.
What did you say? It needs to be a group of 3. What number and variables will be on the outside?
2x.
2x.
When we put cube,
The
yeah.
cube root of what's left?
2.
2. And if you want, you can put parentheses around the cube root. It's not necessary.
Okay.
So it's the same thing. We're just combining things. Jackson.
So what happens again? What happens again? Like if there's 2 left. So like
These aren't actually numbered. Which one are you
on
talking
like
about?
the top right.
What 2 numbers did you start with?
6 and 9.
We're doing this one really fast just because Jackson had a question about it. Because it's good practice so that you see what happens when you have this. Here, this is a square root, so we're looking for pairs, not groups of 3. We have 1 group of 3. We have 2 groups of x's. So on the outside, we know we're going to have 3 times x times x. I'm just going to write it out like this for now. We'll combine them here in a second. Times the square root of 2 times 3. You have to multiply everything at the end. So 3 times x squared times the square root of 6. Everything needs to be combined at the end. Okay.
So shouldn't you say 6x?
Oh, yes. I forgot about that x.
Photo math.
So pairs go on the inside and then the letters on the outside?
I didn't
So
hear
the
that.
pairs of numbers and x's go on the inside and then
The pairs go on the outside. Anything that's not paired goes on the inside.
Okay.
Oh. Okay. I do want to do one more of the cube roots
Okay,
with you.
why would, if 3 and 2 aren't paired, then why did they go on the inside?
They both did not have a pair, so they both went on the inside. For this one, this cube root of 128 x to the 7th, give me 2 factors of 128.
2,
And
4.
2 and 4 is 8. 64 and 2.
I was so close.
Okay. I'm going to do this the easier, faster way. 3 goes into 7 how many times?
2 times 7.
So I know there's going to be an x squared on the outside. And how many left over?
1.
1. There's going to be 1 x inside. I know that much already. I haven't figured out my numbers yet. Those are both a's. They just don't look like it. I'm running out of space, so I'm going to write it off to the side.
Hey, what? Hey, what?
Right here. So in this case, pretend this is underneath this. I don't have space. They're continuing.
64 and 40.
64 to 80.
8. So in this case, we have 2 4s and 2 2s. And normally I tell you to keep going because we need pairs. But if we have this pair of 4s and we have this pair of 2s, we could bring that out. The only reason that works is because these would each be pairs of 2s.
Wouldn't it be crazy?
You're right. I shouldn't be doing pairs. I should be doing groups of 3. Thank you for catching that.
I'm just like a big friend like 4. So
If it was a group of 3, so let me rephrase. If it was a group of 3, we could have taken that. So now we have these 3, these 3.
So now there's 2 groups of 3.
There's there's 2 groups of 3 that have 2 in them. Yes.
So x squared.
So the two groups of 3 would be 2, 4, 8.
4x to the second outside times the cube root of.
I can't do it.
2x. Alright, so next class we're going to continue this. You don't have homework, but you could continue this. I will say that I just put Khan Academy that's not due until the 27th, so you have time to do it. But it's just on what we did today.
I am.